Okay, so now I think through a couple more examples here, um, you should be okay. And if you didn't factor or figure out the problem before number 3, don't worry about that one. That one's kind of a tough one, unless you know how to do polynomial division. So feel free to kind of disregard that one. I know it's a little late now, but this is more like what you'll see on an exam. So look at number 4, where it'll say find the absolute minimum and maximum and minimum on a given interval. Now, up front, I have to apologize. All of this stuff, I don't have any highlighter at the house, and I don't want to go to the stores for fear of whatever thing I might catch. So I tried to kind of cross all that out. So just disregard that for a minute. And try not to peek at my picture over here yet either. If you want, probably another good idea to not look at the screen, to go ahead and try to find the absolute and max mins using your closed interval method first. In other words, set the derivative equal to 0, find that value, and then plug in the endpoints, and then compare the y values. Pause the video for a second, and when you come back, I'll try to give you some explanations. Okay, so if you're back now or just continuing to watch, the derivative of my g function here is just 54 minus 6t squared. Notice now I'm trying to almost assume you can take the derivative pretty quickly. You set it equal to 0, and I moved the 6t squared over just because it was to make it positive, get rid of the negative. Divide both sides by 6, and then you have to square root both sides to get an answer that's plus or minus 3. Now, because I'm only worried about the interval from 0 to 4, I'm not even going to pay attention to the negative value. So I'm going to take that positive 3 value, because it's the only x I found for a critical number between 0 and 4. Again, this is a continuous function because it's a polynomial. Remember, critical values are where the derivative can be 0 or does not exist. But the derivative will exist everywhere. So, at least on this interval, when I plug in 3, I'll get 1/13. So I'm going to store that away and just leave that there for a second. That's my only critical value on that interval. So what you have to do after that, using that closed interval method, is because my interval is from 0 to 4, I plugged in 0 here and 4 here to the original function. And what happens is you'll find that the y values, your biggest one, so and then you have 1 of 5 of 93 here. So 5 is y value when x is 0, 93 is a y value when x is 4. The highest y value you have is there, the lowest y value you have is there. So this is your absolute minimum without looking, and this is your absolute max. What you can do, you can always graph it on your, your calculator, and if you look over here, you'll see that there's my max, and here's my minimum. Now, does that minimum value there, is that allowed? I should ask. What you should be saying is, and be careful, because that's what you'll do, is you'll look at this value and say, hey, this is the lowest value, but that one isn't allowed because it's not on the interval. Remember, they only care between 0 and 4. So what will happen is your absolute minimum, if I clear everything, your minimum is here and your maximum is here, because you're really only testing 3 points. Your other point here is somewhere in between your value for 5, which was when you plugged it, or excuse me, 5 and 90, and 113. So if I wanted to color coordinate that, let me erase this. And when G is 0, that's going to be my minimum. The computer's not taking it. That's my min again. And this is my max. And if I'm doing perfectly everything with colors, that's somewhere in between those values. So that's the absolute min and the absolute max. All right, part B, do that one. Find the absolute max and min values on that given interval using the closed interval method. Pause the video, and when I come back, I'll explain it. Okay, I'm going to move a little bit more quickly this time. Pause the video if you need it to be paused. Take the derivative of a natural log function. So remember, the derivative of natural log is just 1 over whatever's in here, which is why it's 1 over x squared plus 2x plus 4. Now, because the chain rule exists, I also have to take the derivative of the inside, which gives me 2x plus 2. This is my function then that I have to set equal to 0. And if you multiply both sides by x squared plus 2x plus 4, and over here, same thing, x squared plus 2x plus 4, this will go with this. And 0 times anything is itself. So all that really ends up happening is you end up with 0 over this top quantity, which was 2x plus 2. Move the 2 over, that's negative 2, divide both sides by 2. My critical value is where x equals negative 1. Now, again, file that away. So if I clear all my drawings, we're not going to forget that that value is negative 1. Then you have to start checking. Well, you can actually plug that in before you go any further. Let me see if I can put the screen down for you. And I already wrote the answers in, but what I'm trying to show you is I plug in negative 1 into the original function. That was your critical value, but this is the y value. So I should have said that. I apologize. That's the value that you want to hold on till later. Now, the only other thing you have to do is you have to check your endpoints. So your endpoints in this case are negative 4 and 3, respectively. If you plug in negative 4, your y value is 2.48. We'll make that one blue. So that's going to be in blue. And if you plug in 3, your value is going to be 2.94. So you have 3 values. You have 2.48, 2.94, and let's see if I can do this right here. I apologize, I can't get rid of that black line because my taskbar won't move. So I'm not even going to worry about it. Sorry, I have to just deal with it for the time being. Notice your other y value is here at negative 1. So you have negative 1 to choose from, 2.48, or 2.94. So if you're being asked for the absolute minimum, the smallest y value is when x is at negative 1. So that's why your absolute minimum is there. Your absolute maximum will occur at 3. Notice this value of 3 here. So that's the y value. That's the absolute highest. And again, there's some other value in between that you just don't even mention. Hope that helps. Talk to you soon.